Hi, welcome back. We're still in Chapter 1, Section 5. We are skipping Section 4. So we're going straight to Section 5, and we're going to talk about complex and imaginary numbers, all of which you have seen once again. Remember, this whole first chapter is quite a bit of review. The objective of this particular section is to learn how to add, subtract, multiply, and divide complex numbers. Once again, something you've already learned. So we're going to recap because it is important for the rest of the pre-calc school year. So we're going to add, subtract, multiply, divide complex numbers. All right, so if we look at the square root of 64, we should recognize that's pretty easy, that the answer is 8. However, we run across a situation where sometimes we have a negative square root, so we need to figure out what number times what number is equal to negative 64. And the problem is that these two numbers have to be the same. And you should recognize that it's not possible to ever get a negative number when you're multiplying the same number together. Not possible. So a long time ago, probably in the 1700s, some very smart female and male mathematicians came up with a way to solve a problem like this, and it is called imaginary numbers. So what we have here is the definition of an imaginary number. If a is bigger than 0, then the square root of negative a is equal to I square root of a. So this number, this imaginary number, is what helps us solve square roots that are negatives. Okay? So we're going to follow the definition. We're going to solve a couple simple square root problems. So when you have a negative underneath the square root, what you're first going to do is you're going to take out an I, and you're going to leave the number the same. So what we're going to do basically is we're going to watch the movie The Christmas Story, and we're going to take your eye out, which is what they didn't want you to do with the BB gun. Okay. So now once we've taken the I out, we now can solve this problem because we have a positive square root of 25, which we can solve. So the square root of 25 is 5. And then we always put the I at the end of the problem. So the answer is 5I. That should be familiar. You should have seen that at some point. Okay, so the next thing we're going to do is the square root of negative 28. So the first thing we're going to do is take our I out, and then we're going to square root 28. So you should recognize that that can be simplified. So let's break it down to two square roots, where one is on our list of perfect squares, and you should remember that it's 4 times 7. What is the square root of 4? It's 2, and then square root of 7. So please remember, your whole numbers are always in front of your I, and then your square roots come at the end. So 2I root 7 is your final answer. Okay? So those are the easy ones. Let's get a little harder here. Please remember, oops, I don't know what that is, sorry. Please remember, you have to remember this, you should remember this, that I squared, anytime you have an I squared, it's equal to negative 1. Okay, so you have to remove the, always have to have a negative. You've got to get rid of I squared. You can never leave that in an answer. Okay? So we're going to use that in a little bit. But first, let's look over here at these examples. We have the square root of negative 9. You always have to take your I outs first. So I have I root 9 minus 2I root 25. Okay, so now what is the square root of 9? It's 3. So we have 3I minus. What is the square root of 25? I have 2I5. And let's keep going here. 2 times 5 is 10. So now what do we have left? We have 3I minus 10I, which is negative 7I. Okay, so I's act just like variables. Okay. Example 2, we have I root 3 times I root 6. I cannot simplify either of these, okay, but I am going to multiply like terms. So I have an I times an I, which is I squared. And I have root 3 times root 6, which is square root of 18. Now we can simplify some things here. So from right above here, we have to remember that I squared is negative 1. So we have to simplify I squared to be negative 1. and then break down square root of 18 to 9 times 2. And now let's keep going. We have negative 1 times square root of 9, which is 3, times square root of 2, which cannot be simplified. Negative 1 and 3 is negative 3 root 2. Okay, so a little bit harder. Just remember that this is a multiplication problem, so you can multiply I times I. Okay. When you're adding and subtracting, you can only add and subtract like terms. So 3i minus 10i is negative 7i. Very good. So part 2 of this section is talking about complex numbers. Complex numbers are in the form a plus bi, where the first number is a real number, and the second number is an imaginary number. Imaginary number. I'm not sure why I spelled that out. I should have just used a symbol, but that's okay. So for example, 3 plus 6i is a complex number. It's complex because it has a real portion and an imaginary portion. You could also have negative 6 minus 6i. That would also be complex. The signs can be either negative, subtraction, or positive, okay, for complex numbers. So now what we're going to do is we're going to do 4 operations with complex numbers. We're going to start with the easy, and then we're going to get a little bit harder. So our first problem we're going to do is a simple addition problem. You can only add things that are like terms. So I'm going to do 2 plus 4 to get me 6. So you can add the 2 and the 4. And then we're going to do 3i plus 5i, which is 8i. So it always has to be a real number plus your imaginary number. You cannot do 8i plus 6. That does not work. We cannot do that. That is not the correct form. Okay. We're going to skip down to number 2 here. Okay, so now instead of adding, we are multiplying. They're right next to each other. So what we're going to do is FOIL. So we're going to do first times first, which is 2 times 4 is 8. Then we're going to do the outer 2. 2 times negative 5i, which is negative 10i. Then we're going to do I, which is the inside. So 3i times 4 is 12i. And then we're going to do the last 2, which is 3i times negative 5. So negative 15. And then I times I is I squared. Okay, so let's simplify. We have 8. Negative 10i plus 12i is 2i. And then we have negative 15 times I squared. But I squared, we have to remember, is negative 1. So what do we get? So we have 8 plus 2i plus 15, because negative times a negative is a positive 15. And then we're going to write our final answer, which is 8 plus 15, which is 23, plus 2i. Okay, so foiling. Okay, that's multiplication. Now what we're going to do is we are going to subtract. Okay, subtracting is the same thing as adding. We can only subtract things that are the same. So first thing we can do is 2 minus 4, which is negative 2. And 3i minus a minus, so that turns into a plus. 3i plus 5i is 8i. So we have negative 2 plus 8i. So please remember, do not do 8i plus negative 2. Okay, not good. Whole number comes first, imaginary number comes second. Moving on, so we've done adding, we've done multiplying, we've done subtracting. Our next portion is going to be dividing. And in order to divide, we need to use something called the complex conjugate. Okay, but really what we're doing is we're doing a fancy way of multiplying something by 1. So what you're going to do is you're going to take the bottom complex number and you're going to multiply it, but what you're going to do is you're going to switch the signs. So instead of being a plus 3i, you're going to do a minus 3 on the top and the bottom. Okay. So what I like to do is I like to put parentheses around everything, and then it's a very tedious process, but I think you can handle it. What we're going to do is we're going to FOIL the top and we're going to FOIL the bottom. Okay. So let's do some foiling here. So we have 5 times 4, which is 20. We have 5 times negative 3i, which is negative 15i. we have negative 2i times 4, which is negative 8i. And we have negative 2i times a negative 3i, which is positive 6i squared. Okay, let's do the bottom now. We have 4 times 4, which is 16. We have 4 times negative 3i, which is negative 12i. We have 3i times 4, which is positive 12i. And we have 3i times negative 3y, which is negative 9i squared. Okay, so what we need to do next is what we need to do next is we need to simplify the tops and the bottoms. So we have negative 15i minus 8 more I, which is negative 23i. And then what are we going to put in for I squared? That's negative 1, right? So we have 6 times negative 1, which is negative 6. So what's 20 minus 6? That should be 14. Okay, so the top is 14 minus 23i. Let's now do the bottoms. And what do you notice about the i's on the bottom? Negative 12i plus 12i cancel. So multiplying by the complex conjugate gets the i's to cancel on the bottom, which is what we want. So remember, I squared is negative 1. Negative 9 times negative 1 is positive 9. 16 plus 9 is 25. Okay. The last step you need to look at is as long as all three of these numbers cannot be simplified, you are good. There is not a single number that goes into 14, 23, and 25, so this would be our final answer. Okay. So that is good. So we're going to do one more of those, and hopefully this will, I don't know why that keeps happening, sorry. We're going to do one more of these problems. We're going to multiply by the complex conjugate. Okay, we're going to multiply by the complex conjugate, which for this one now would be 2 minus I. 2 minus I. Okay, so let's see what we get. This one's a little bit shorter. It's not as in depth. Okay, so what's 1 times 2 minus I? Well, that's 2 minus I. On the bottom, we have to FOIL. 2 times 2 is 4. 2 times negative I is negative 2I. I need to extend my fraction bar here. I times 2 is positive 2I. And I times negative I is negative I squared. Okay, so on top we just have 2 minus I. On the bottom we have negative 2I plus 2I. Those cancel. So remember, the i's always cancel on the bottom. This I squared is equal to negative 1. So we have a negative negative 1, which is really positive 1. 4 plus 1 is 5. So we have 2 minus I all over 5, and you are done. Okay, so hopefully that makes sense. Lastly, for this section, we have one more problem, which is example 6. It says, show that 2 plus 3i is the square root of negative 5 plus 12i. So what I want you to show is that the square root of negative 5 plus 12i is equal to 2 plus 3i. Okay, so that's what they want you to show. Okay, so how do you think we are going to do that problem? Okay, so what this means is, okay, so anytime you take the square root of something, it's saying that 2 plus 3i times 2 plus 3i should equal negative 5 plus 12i. That's what square root means. What two numbers multiplied by each other equal the number under the square root? Okay, so let's show that really quickly. So we need to show that 2 plus 3i times 2 plus 3i is equal to negative 5 plus 12i. So let's FOIL. Okay, let me switch the color here. We have 2 times 2, which is 4. We have 2 times 3i, which is 6i. We have 3i times 2, which is 6i. And then we have 3i times 3i, which is 9i squared. Okay, so let's simplify our i's. We have 6i plus 6i, which is 12i. Remember, I squared is negative 1. 9 times negative 1 is negative 9. 4 minus 9 is negative 5. So we have now shown, as you can tell, negative 5i plus 12, negative 5 plus 12i. So we've shown that 2 plus 3i is the square root of negative 5 plus 12i. Okay. So hopefully that makes some sense. And that wraps up Chapter 1, Section 5. I believe there's one section left, and then we're going to have our chapter test. Hopefully you enjoyed. Hopefully this is working out well for you. Have a good night, and I will see you tomorrow.